Hello, 7th graders, and welcome to 4.2. In this lesson, what I want you to be able to do is find equivalent ratios and identify proportions. Okay, we're going to start today with a little bit of vocab, and then I'll give you a few examples and even a few of my own examples, and to help you with identifying proportions. Okay, so let's start by defining a few different terms. So the first one is equivalent ratios. And those are ratios that name the same comparison. Okay, that would be one example I always use of this is pizza. Okay, so you have two pizzas, and in one pizza, this first pizza, you just cut it in half. Okay, and there's just two really big slices, and you eat one of the two slices. Okay, and in the second pizza, you cut it into fourths, and you eat this first piece, and then you decide, well, I could have another piece, and you eat the second piece as well. Even though it's cut into two different sizes, so this one is cut into 2 and this one is cut into 4, you actually ate the same amount, because in this pizza you ate 2 out of the 4 slices, and in this pizza you ate 1 out of the 2 slices, but these slices are twice this, so you ate the same amount, and 1/2 is equal to 2/4. I know that's really basic, but that's what it means when it says that these are two ratios that name the same exact comparison. You ate the same amount of pizza. Okay, and a proportion then, for the next vocabulary word, is an equation stating that two ratios are equivalent. Okay, so that's actually, this here is the proportion. Here's a ratio, and it's saying it is equal to this other ratio. Okay, so there's a little bit of vocab. Let's try one of these examples. For example 1, it wants us to determine whether the ratios are proportional. Okay, so there's a few different ways to go about this. One way you could and the first way that we'll do this is to simplify your two numbers or your two ratios. Okay, so for the first one, I have 24/51, and the second number I have 72/128. You can see if this was pizza, this one would be cut into 51 pieces, and this would be cut into 128 pieces, just like in the previous example. And we need to determine, are these two proportional? Well, what we're going to try to do is put them in simplest form and see if they equal each other. Well, you can start looking for numbers that are divisible by both your top and bottom number. So you see the book here did 24 divided by 3 and 51 divided by 3. Okay, 24 divided by 3 would give you 8. And 51 divided by 3 would give you 17. And again, they're just saying simplify this fraction. So that would be 8/17, and now 8 and 17 do not have any more common factors, so we can't simplify these two anymore. Go on to your second number, 72 and 128. They're both divisible by 8. 72 divided by 8 is 9, and 128 divided by 8 will give you 16. And now 9 and 16 don't have any common factors, so this is also in simplest form. So since 8/17 is in simplest form, and so is the other fraction, 9/16, they do not equal each other. So the ratios are not proportional. okay, because they're both in simplest form and they're not the same number. Let's try letter B and use that same method of simplifying these two first numbers. 150 and 105, well, they both end in a 0 or a 5, so I know we could divide them by 5, but there's a greater number that they're both divisible by. Again, in this section, I'm okay if you want to use your calculator to check divisibility rules. So maybe you said, okay, I know it ends in a 0 and a 5. I'll divide them each by 5. Okay, so 150 over 105. If I divided each of those by 5, 150 divided by 5 would give you 30. And 105 divided by 5 would give you 21. Look at these numbers and say, oh, well, you can be simpler because they're both divisible by 3. So that would give me 10/7 if I divide them both by 3. Now it's in simplest form, right? And so I actually divided by 15. 105 divided by 15 is 10. 150 divided by 15 is 10. And 105 divided by 15 is 7. You can see here I just divided by a different number right away, by 5, and then I went even simpler. Okay, so the first number simplified is 10/7. Let's check our next number. I've got 90 and 63. They're both divisible by 9. 90 divided by 9 is 10, and 63 divided by 9 is 7. Hey, look at there. So since 10/7 is equal to 10/7, the ratios are proportional. Okay, so for letter B would be yes, they are proportional. The other way that I'll let you know that you can check and see if these are equivalent is you could just remember this is the same thing as dividing. You could punch in 150 divided by 105 in your calculator, and it would come up with punch in quick 1.428571429. Okay, and if I did the same for the other one, 90 divided by 63, that gives me the same exact answer. 1.42857, blah, 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 blah. All right, that's another way to check and see, are those two proportional? Wonderful. Go ahead and flip your page to example 2. And in this example, it's a word problem. And we're going to solve it a different way. Instead of simplifying this time, what we're going to try to do is get common denominators. Okay? So instead of simplifying, we're going to try to get a common denominator. Again, this is just another way to show you how you can find proportions or check to see if ratios are proportional. This will work too. So it says directions for making 12 servings of rice calls for 3 cups of rice and 6 cups of water. For 40 servings, wow, that's a lot of rice, the directions call for 10 cups of rice and 19 cups of water. Determine whether the ratio of rice to water are proportional for both servings of rice. Okay, so what we need to do first is write the ratios of rice to water for both 12 servings and for 40 servings. Okay, so for rice to water for our 12 servings, so here was 12, rice was 3 cups and water was 6 cups. So 3 cups to 6 cups. And for 40 servings of rice to water, it was 10 cups of rice to 19 cups of water. All right. And what we're going to try to do is get a common denominator between 19 and 6. And it might not be obvious, but remember what you can always do is you can multiply this denominator by the other denominator. So I can multiply this by 19. So taking this, all right, I'm back. And what I was saying was that you can multiply your denominators by each other. So you notice they multiply 3 6 by this denominator. So 19 right here is being multiplied by that 3 6 on top and bottom. And the other denominator, 6, is we're multiplying by this other ratio. And the reason being is because that's going to give us a common denominator. So on top, we'd have 3 times 19 would give us 54 over, and 6 times 19 would be 114. And in the other fraction, 10 times 6 on top would give us 60 over, again, now 6 times 19 was 114, so 19 times 6, 114. Okay, so we wrote the ratios with a common denominator, such as 114, and then compare their top numbers. This is 54 1/14, and this is 60 1/14. So definitely not the same, since 50, oops, sorry, I messed this up. This is 57. I just caught that now. Since 57 1/14 does not equal 60 1/14, the two ratios are not proportional. They're close, right? This is only 3 away. And you might have been able to tell that right away, because for 12 servings, it was 3 to 6. Well, 3 is half of 6. So if this second one were to be proportionate, 10 to 19, 10 is not half of 19, 10 is half of 20. So it is if it were 10 over 20, then you could say, well, yeah, because 10 is half of 20 and 3 is half of 6. These would both simplify to a half. So that would work. But since it's not, since it's 10/19, it's close, but they are not proportional. All right, moving on to example 3. We've got an A and a B, and then we've got 3 check it outs to finish up. So for the last one, it says find an equivalent ratio and then write the proportion. Okay. So to find an equivalent ratio, there's quite a few ways you can do it. The easiest way is just to multiply by 2. Make it twice as big. Just like I did with my pizza example. At first, I only cut it in half, and then I cut it twice to cut it in fourths. So I just essentially cut it again, or multiply by 2. So that's the easiest way to do it, and that's what I would recommend for you to do to start out. That's going to be pretty nice way to do it. So on top, 3 times 2 would give you 6, and on bottom, 5 times 2 would give you 10. So you need to multiply both the numerator and the denominator by any number, but the easiest would be just to multiply it by 2. Okay? So again, 3/5 is equal to 6/10. That is our proportion. One ratio is equal to another ratio. That's the definition of a proportion. For the other example here, we have 28/16. Well, sometimes it's convenient, instead of multiplying by 2, you could also divide by, if they have a common factor that you could divide by, like here, you could divide each by 4, and it would give you a nice, neat whole number. Sometimes that's also a good way to do it. So 28 divided by 4 would give you 7, and 16 divided by 4 would give you 4. So again, we divide both the numerator and the denominator by any number, So again, you can pick any number here, but we just said since they're both divisible by 4, that's a nice, easy way to do it. Let's not make this more difficult than what it needs to be. So 28/16 is equal to 7/4. Again, write a proportion. Now say you want to, say you had 3/5 and you multiplied top and bottom by 3. Is that okay to do? Yeah, that will give you the same proportion. Well, it will give you a proportionate answer, not the same one, but it would work. 3 times 3 is 9, 5 times 3 is 15. That would work if you had this as well. So a lot of different ways to tackle these problems. Finishing up, please pause the video now and try the 3 check it out problems, 1, 2, and 3 on your own, and then come back to check and see if you were right. Okay, number 1, checking to see whether they're proportional. I have 54/63 and 72 over 144. Okay, is there a number that both of these are divisible by? And maybe for the first one you saw 9. So if you did 54 divided by 9, you'd get 6. If you did 63 divided by 9, you'd get 6/7. And for the second one here, it looks like these are both going to be divisible by, 72 is half of 144. So you could divide by 72 actually. 72 divided by 72 would be 1, and 144 divided by 72 would be 2. So is 6/7 equal to a half? Definitely not. So determine whether they're proportional. They're not proportional. Okay. Next one, similar to the rice one, we're going to see is the ratio of beans to water proportional for both servings. Okay, so for a serving of 8, we've got 4:3. For a serving of 35, we've got 13:9. So 4 cups of beans to 3 cups of water. Is that equal to 13 cups of beans to 9 cups of water? Well, what you could do is you could say, this is in ninths. I could put this one to ninths by just multiplying by 3. So that would give me 9. Then if you multiply by 3 here, you'd have to multiply by 3 on top, which would give you 12. So does 13/9 equal 12/9? And the answer would be no. It's close, but it is not proportional. And the last one says find a ratio equivalent to the ratio and then use the ratios to find a proportion. Okay, 16 and 12. Remember, you could multiply by 2 or divide by a number. Well, since I see that they're both divisible by 4, I'll divide by 4 on top and bottom. And that would give me 4/3. So that would be an equivalent ratio. And then to write that proportion, I would just write 16/12 is equal to 4/3. And there's an answer. All right, that wraps things up for us here today. If you have more questions, please let me know, and I will see you next time.